Have you ever wished you could just make it rain on command? Well, for the better part of a century, that's exactly what scientists have been trying to do. So today, we're going to dive into the fascinating and pretty controversial world of cloud seeding.
At its heart, weather modification is really just an attempt to give nature a little nudge. And when it works, it can feel incredibly powerful, almost like magic. But how do you actually turn that feeling, that near magic, into real science?
Well, it all starts right here. Cloud seeding isn't about creating clouds out of thin air. It's really about making the clouds that are already there way more efficient at producing rain or snow. You could almost think of it like being a precipitation coach, just helping the cloud perform at its absolute best.
Okay, so how exactly does this coaching work? Let's get into the mechanics of how you actually seed a cloud. I love this quote. It's such a brilliant way to put it. See, in a lot of clouds, water droplets can get what's called supercooled. That means they stay liquid even when the temperature drops way below freezing. They need a little help, like a template, to figure out how to turn into an ice crystal. And that's the exact problem cloud seeding tries to solve.
And here is that solution in action. You have seeding agents, something like silver iodide, that get released either from the ground or from an airplane. They act as these little ice nuclei, basically templates for ice to form on. As they drift up into the clouds, those supercooled water droplets latch on, they freeze, they form ice crystals that just grow and grow until they're heavy enough to fall as snow or rain. Pretty cool, right?
And of course, there are different tools for the job. Silver iodide is the classic. Its crystal structure is a near-perfect match for an ice crystal, but it needs pretty cold temperatures to work. Then you have liquid propane, which works in a totally different way. It creates this intense little pocket of cold that basically forces water droplets to freeze on their own, and that makes it effective in slightly warmer conditions.
So how do you get these agents up into the clouds? Well, there are two main ways. You've got ground-based generators, which are often used in mountains, and they just let the wind do the work of carrying the particles up. The other way is to use aircraft, which can fly directly into or even above the target clouds for a much more precise delivery.
All right, now we get to the multi-million-dollar question. And this is where things get really complicated. For decades, the science has been debated. So what does the evidence actually say? Let's just tackle this head on. I mean, if you're spending all this money to shoot particles into the sky, you really want to know if you're actually getting more rain or snow out of the deal. This is the number you're going to hear most often from supporters. Successful programs typically claim they see a seasonal increase in precipitation of about 10 to 15% over what would have fallen naturally.
For the longest time, the huge challenge was just proving cause and effect. How can you be sure that the snow that fell was because you seeded the cloud and it wouldn't have just fallen anyway? Well, that's where the 2017 SNOWY project in Idaho was such a breakthrough. For the first time, researchers used advanced radar to literally watch the entire chain reaction happen in real time. They could track the plume of silver iodide from the plane, see the ice crystals form, and then watch those crystals grow into snowflakes and fall to the ground. It was the smoking gun, a clear, observable link from seeding to snowfall.
But, and this is a big but, there's a really strong counterargument. Israel ran these cloud seeding experiments for years, and at first, everyone thought they were a huge success. But a later reanalysis of all that data found something really interesting. The days they chose to seed were just naturally wetter days to begin with, and once they corrected for that, the effect completely vanished. Their statistical measure of effectiveness came out to 1.00, which basically means no net increase in rain. Okay, so with this scientific debate in the background, what are the real-world implications? This brings us to some really practical questions about safety, fairness, and of course, money. This is probably the first question that pops into most people's minds, right? Are we just pumping harmful chemicals into our environment? So to put this in perspective, let's look at the main agent, silver iodide. The amount released from cloud seeding is just a tiny, tiny fraction of the silver that's already in the atmosphere from all other sources. I mean, we're talking 0.01%. Study after study has found that the concentrations are way below any safety standards for drinking water or aquatic life. This is the other big ethical question. If you make it rain more in your backyard, does that mean you're taking water away from your neighbors downwind? It's that classic robbing Peter to pay Paul dilemma. Well, the science suggests that this really isn't the case. Storms are actually surprisingly inefficient. A typical storm system only releases about 10% of the water it's carrying. Cloud seeding just aims to boost that efficiency by a tiny bit, maybe up to 11%.
That leaves a whopping 89% of the storm's moisture to just keep on moving, which means it has a pretty insignificant impact on any areas downwind.
Okay, so if it's considered safe and it doesn't seem to steal rain, does it make financial sense? Well, the benefit to cost ratios can be absolutely huge. For every single dollar spent on cloud seeding in North Dakota, they see $15 to $25 back in agricultural benefits. And just look at Texas, a stunning 235 to 1 return on investment, mostly by refilling groundwater. So yeah, where it works, it can pay for itself many, many times over. All of this brings us to the future. In a world that's facing more water stress and a changing climate, what role could a technology like this actually play? Well, the technology is already adapting. Remember how we talked about liquid propane working in warmer conditions? As winters get warmer because of climate change, some storms that would have been perfect for silver iodide seeding are now just too warm. So programs are now experimenting more with liquid propane to try and extend their seeding seasons and adapt to this new reality. And that really leaves us with this final thought. The science is still being worked out, and let's be honest, the idea of meddling with the weather, it's always going to carry a certain weight. But as fresh water becomes more and more precious, the question might start to change from can we do this to do we have to? It's a huge debate between caution and necessity, and it's one we're probably going to be grappling with for a long, long time.